Question 1. The mean is 60. The standard deviation is 4. X is a normal distribution. They want to know the probability that X is less than 53. So, drawing a picture of the normal distribution, 60 is the mean, 53 is to the left, and the region of the bow that is less than 53, below the curve, is a left tail. We're going to have to convert these x values to z values using the conversion formula x minus mu over sigma. Now in this case, mu is 60, sigma is 4. Now notice if I replace 60 for x, 60 minus 60 is 0, and 0 over 4 is 0. So the mean became 0 as a z value. We know that already. We can always put 0 for the mean as a z-score, but we're going to have to convert 53. (53) minus 60 divided by 4 gives us negative 1.75. So we're going to have to use our z-table to deduce the answer. We'll use our z-table to deduce the percent of the bow that is not shaded. We don't know what that is. Since we can use symmetry and a positive z-table for z-scores, we look for row positive 1.7, column 0.05, and we'll find 45.99. 45.99%. So 45.99% of the bow is not shaded on that whole left side. Taking 50 and subtracting the 45.99 will give us the answer. And we know that 4.01% of the bow is shaded. This is the answer. So, if we write 4.01% as a probability value, it is 0.0401. Question 3. The mean here is 22. The standard deviation is 2.4. X is a normal distribution. They want to know the probability that 19.7 is less than X, which is less than 25.3. The center of the distribution is 22. 19.7 is to the left of 22, and 25.3 is to the right. if we shade percent of the bow that's between 19.7 and 25.3, this is what we have to deduce here to answer the question. What percent of the bow is shaded? Now again, we have to convert using x minus mu over sigma. In this case, mu is 22 and sigma is 2.4. The center, or the mean of the distribution of 22, easily becomes 0. But what we have to convert is both 19.7 and 25.3 using this conversion formula. .4 is a standard deviation. 19.7 minus 22 divided by 2.4. So it looks like, approximating this to the nearest tenths, the z-score is a negative 0.96. Converting 25.3 we find a 1.375 or 1.38 if we approximate to the nearest hundredths. We are going to use our z-table to determine the percent of the bow that's shaded between negative 0.96 to 0, this left side, and between 0 and 1.38, the right side. So, 0.9 row, 0.06 column, .9 row, 0.06 column, we find 33.15 or 0.3315. That's on the left. We now need to look for 1.38. .3 row, 0.08 column, we find 4162. That's 41.62%. So if I take the 33.15 plus 41.62%, and add these, we get 74.77%. This is our answer. We have the left portion and the right portion. .77% becomes 0.7477 as a probability. Problem 5. The mean here is 1100, while the standard deviation is 150. X is a normal distribution, and X represents the income of the trainees. They're looking for the probability that X is less than 900. Drawing our normal distribution, 1100 is the mean, 900 is to the left, less than 900 gives us a left tail. We need to convert using our conversion formula, z equals x minus mu over sigma, or in this case, z equals x minus 1100 over 150. Now, converting to z values, the mean of 1100 becomes 0, but we have to determine what 900 becomes. We'll have to plug in 900 here. (900) minus 1100 divided by 150. We get negative 1.33. So we're going to have to determine the percent of the bow that's not shaded. Whatever that is, we are going to subtract it from 50, which is half the bow, the whole left side. Using the Z table, we'll look for row 1.3, column 0.03. 1.3 row, 0.03 column gives us 0.4082. That corresponds to 40.82%. So our 50 minus 40.82 gives us 9.18%. That is, 9.18% of the bow is shaded in a left tail. That means, as a probability, it is 0.0918 for an answer. Number 7. The mean here, mu, is 200, with a standard deviation of 50. Now, X is normally distributed. X represents the ratings. So in question 7, they want to know, what's the probability someone has a rating between 200 and 275. Drawing the normal distribution, center being 200, that's the mean. The question is, what percent has a rating between 200 and 275? Between 200 and 225 is shaded in this region here. Using our conversion formula, we're going to find x minus the mu over sigma, the standard deviation. In this case, mu is 200. The standard deviation is 50. So we're going to need to convert 275. We get z is 1.5. (200), which is the mean, is always 0. So we're going to need to look at our z-table to deduce the answer. We will look for the 1.5 row, 0.00 column. And we find 4332. So that means this is 43.32%. As a probability, 43.32% is 0.4332. Question 9. The mean is 268 with a standard deviation of 15. X is normally distributed and represents the number of days pregnant. They want to know what's the probability that X is at least 300. That is greater than or equal to 300. Drawing our normal distribution, the mean is 268, 300 is to the right, so at least 300 is a right tail. Using our conversion formula of z equals x minus mu over sigma, or simply z equals x minus 268 over 15 for standard deviation. We know these x values need to be converted to z values. 268 is 0. We need to know what 300 is as a z value. (300) minus 268 divided by standard deviation here is 15. We get a z-score of 2.13 rounded to the nearest hundredths. We're going to use our z-table to determine the percent of the bow that's not shaded between 0 and 2.13. This is a right tail, so the answer is going to be 50 minus that percent of the bow that is not shaded. Z 2.1 row, 0.03 column, you get 4834. 4834. That means 48.34% of the bell. So taking 50 and subtracting 48.34, we'll get 1.66. That's 1.66%. 1.66% of the bell is in the right tail. The answer as a probability is 0.0166. Question 11. X represents the light bulbs, the lifetime or the lifespan of your light bulbs. The mean mu is 392 with a standard deviation of 9. In this question, we have to use the backwards formula, meaning X is mu plus Z times sigma. Drawing the picture, (392) is the mean. They want us to find the value of X that represents the bottom 25%. Let's draw a little picture closer to scale so that this is supposed to be 25%. We need some value of X that represents the bottom 25%, or first quartile. P25. So what we're going to have to do, we know 392 as a z-score is 0. The key is to find the z-score associated with the bottom 25%. So if this is a left tail that's 25%, what's not shaded is also 25%. 25% is not shaded, 25% is shaded. So the backwards formula is X equals 392 plus Z times 9. Find the z-score associated with 25%. Working backwards. I have to find a row and a column associated with 25%. Now to be clear, it's this picture. This is what my z-table works for, from 0 to some z value. It just is by coincidence 25% of the bell is shaded as the left tail. So working backwards, looking for 25%, we see 2486 and 2517. 2486, 2517. Now, What that means is 25% is really somewhere in between 2486 and 2517 approximately. This is about 17 over, this is 14 under. So it's approximately between these two. So if we find the z-scores that are represented here, we can take the mean, which is they're both in the 0.6 row. This is the 0.07 column, 0.08 column. So the z-scores are really 0.67 and 0.68. 25% is approximately between these two numbers. So if I look at 0.67 plus 0.68 divided by 2, let's double check. 0.67, 0.68, a z-score that's between these, midway between, is found by adding them and dividing by 2. Add them, divide by 2, we get 0.675. We're going to use this z value, this z-score, and that's going to get us close to that 25%. 0.675. Remember, we were looking for that z-score. It's to the left of 0, so it's negative 0.675. And this gets us pretty close. It's not exact, but it's close. So if we plug this in our calculator, 392 minus 0.675 times 9, we get 385.925. So 385.925 represents the value of the first quartile. Or you can say about 386 days. Question 13. X is the amount of a phone bill, and it's normally distributed with a mean of 76 and a standard deviation of 12. They want us to determine the first quartile value, or the bottom 25%. Drawing a picture. The mean is 76. Some x value represents the bottom 25%. As you know, what is not shaded here is also 25%, because the sum of the left sides is 50%. As a z-score, 76 is 0, and the key is finding the z value associated with this picture. Working backwards, x is mu plus z times sigma. In this case, x is 76 plus z times 12. If we determine z, we can plug this in our backwards formula and find the value of x that represents the 25th percentile or the bottom 25%. Now, from the last example, I believe we found a z-score of negative 0.675. Let's double check. Yes. So, using the z-score that represents the bottom 25%, we plug this in our backwards formula, and we can deduce the value of x. (76 minus 0.675 times 12). We get 67.9. This is the value of x. Looks like this is the phone bill amount that represents the bottom 25%. First quartile value, 25th percentile. Question 15. The height is normally distributed, and we have a mean of 63.6 inches with a standard deviation, sigma, of 2.5 inches. They want the height that represents the third quartile. So let's draw a picture. (63.6) normal distribution. Now, we can look at this various ways. Third quartile value is really the 75th percentile value. That implies that this must be 25%. The left, remember, is 50%. So 50% plus 25% gives us our 75%. This value of x, working backwards, will give us the value representing the third quartile. Now again, the key is to know the particular z-score associated with this picture, because working backwards, x is mu plus z times sigma gives us, in this case, 63.6 plus z times 2.5. It'll give us the value of x that represents the third quartile. Again, the key is knowing the z-value associated with that picture. From the past problems, we deduced the z-value associated with this 25%. That z-score was 0.675. In the past, it was negative because it was to the left of 0. It was the first quartile value. Here it'll be positive. So if we use the backwards formula with z being positive 0.675, right here, we will deduce our answer. So I will rewrite this with the backwards formula in mind, so we could determine the value of x, or the height. X is 63.6 plus 0.675 times 2.5. we get 65.2875. Approximate this to the nearest tenths, and we get 65.3. So the height that represents the third quartile or 75th percentile is 65.3.